Okay, welcome back. We just finished solving a normalization issue, and we did it in the database. So we could make this guy go away because we don't need him anymore, right? I mean, you could. I'm going to leave it there just because I'm lazy. But so now I have an equipment table and a repair table. So the first thing I'm going to do is I'm going to do a join that puts this thing back together just as if it was before we did the normalization, okay? So that's what we're going to do. So I'm going to go here and I guess I could, I'm going to just go here and say new query. All right, so let's see how this thing works. So if I said select, I'm going to use asterisk and we'll come back and fix that. Asterisk from equipment. And then join. I don't know. Oh, remember, we'll have to do that refresh thing because IntelliSense doesn't know. Shift Control R. Shift Control R. Because I really like this guy to have spell check in front of me. I want to join on repair. And then it's sort of like a where clause where you do on and then equipment dot, and it's going to be the item number equals the repair dot item number. Okay, let's run this and see if it works. And ta-da! It's almost exactly what they had at the beginning. Okay, almost exactly. Only thing here is we have the item number twice. I mean, I just was lazy and used asterisk here. I mean, I could have spelled out the columns exactly the way they had it, but I didn't. Okay, and I think the original one had an order by on the. Well, let's just go take a peek. Yeah, it had an order by on that. Maybe, probably an order by on the item number and the repair. Maybe, kind of hard to tell. Hey, let's do that. What the heck? It's no harm. So, order by is one of the last things. In fact, I'm gonna, since this is getting long, I'm gonna say order by, and if I do item number, I have to tell which one of the item numbers I want. So I want equipment. Dang. Equipment dot item number followed by repair number. Hey, how come I don't have to do the dot thing on repair number? Well, it's not ambiguous. The only thing that's ambiguous is the item number. This only appears once in the columns. This only appears once in the column, once in the column, once in the column. This appears 2 times in the column. All right, so let's execute that. And that looks kind of sort of like that. Okay, so we've done it and then we've undone it. Okay, so it's kind of important that you understand that to undo normalization, to get it back to the way you had it, you do a join. Okay, so let's just stop for just a second and talk about, wait a minute, now this is a little complicated thing. Do we have to do this all the time? And the answer is, well, okay. There are some scenarios where you can go too far, okay? Let me give you an example. Let's say, I don't know, you're a small shop. It doesn't matter what it is you do for a living. You could be, tire repair or something. And you have a list of customers, and you could say that the customer's address to include the zip code. That you could say the zip code determines the city, or the city determines the zip code. You could say that there's a transitive relationship in there, okay? You could say that. The problem is, I don't want to have to maintain the zip code. I mean, I could go to the, U.S. Postal Service and probably pull down a updated list of city, state, and zip code in some database format and use it in my world. But then that means, every couple of months I have to go in there and update that table? I don't want to do that. I mean, I'm doing tire repair. I'm in the tire repair business. I'm not in the zip code business. I just flat don't want to do that. So there are some places where you just don't go that far for lots of reasons. Another reason why you might want to not have everything absolutely perfect is, let's say, for example, you have a price list of things. And then the price list changes. Let's say once a month, the price list changes. But somebody places an order last month, and they got whatever that was. They got kumquats for $4 a piece. And then the price changed. Well, I don't want to have a referential integrity issue where you go back in time and pick an old invoice from a month ago and have its price change. Wow. No, historical data ought to be you ought to copy the data over. So there's no referential integrity there determining what the price is. You might think and go, well, there's no need for me to include the price over here. But yeah, from a historical perspective, you do. Okay, for other things, maybe not, but from a historical. So whenever you have historical stuff, like your pay, okay? So let's say you have, I don't know, your employee table has your hourly rate, and you got a 10% raise. Well, then you go back from last month, and your pay has changed on the system. You go, whoa, I want my money. Well, you don't get money because last month your pay was something else, right? So historical. And then, quite frankly, there's a lot of times there's just no risk of modification anomalies. I mean, not really. The classic example of that is just things like no one's going to mess with the zip code. I mean, you're probably just going to go grab it off of some official source and plop it in place. And so there's practically no problem with modification anomalies. Okay, so I'm going to show you an example. This is a crazy example of another reason why you might want to break up tables. Okay, so these other examples of reason why you would not break them. So now I'm talking about another reason for why you would break them. Okay, so here's a very complicated database. I mean, it has got a gazillion tables in it, and tons and tons and tons and tons of stuff. And quite frankly, a lot of this stuff is duplicates, okay? But the reason why this particular database works is this is an application that will allow the user to determine what data they want. For example, this is about computers. So for example, if I wanted to know about the CPU, I'd collect data on that table. If I wanted to learn about, I don't know, the internet activity, well, then I would collect data on that. But you could optionally turn off those features. You could just select, here's a menu of all the features you want. You just put a checkbox by the ones you want and the ones you don't want. So I need a database design that has that kind of flexibility. I don't want to have tables with referential integrity that have no data, okay? So this is the way you do it. You break it up into tiny little pieces, even though reality is you probably didn't need to break it up into tiny pieces. I mean, for example, here's one called System Info. It's a one-to-one relationship, system information. So in theory, I could just, make the columns wider, right? And add the data because there's no need to have a separate table. But I did it because maybe they don't want to collect that data. All right, I'm not sure if I explained that well, but the point is, if you have an application where tables are optional, where sometimes you fill them and maybe somebody else using the exact same application would not fill them, well, then you have to have a way to make your database efficient. And this is the way it's done. Whew, okay. I mentioned archiving. So you can't change the unit price in a historical context. If I place an order for Beanie Babies at $4 a piece last month, I can't go to Amazon and type in my order and see the price change. That's not going to work. So historical data needs to be copied. And we're only talking about one column, okay? We're not talking about an awful lot of duplication. But one column gets complicated. Okay, good. Another thing, while we're talking about this has nothing to do with normalization, but just while we're talking about it, did you know that it's very rare that databases actually do deletes? That's actually fairly rare thing in the commercial world. Let me explain what I mean by that. Let's say you have a bunch of customers, and customers come and go, and so you might think, well, that's not a valid customer anymore. I don't need sending them advertisements and stuff, so I'm going to delete them. But if you delete them, well, then you don't have any historical data. Okay, let me give you another example. Let's say you're an employer and you have 100 employees, and Bob decides to retire, and so Bob retires, and you delete him off the employee table. Well, then you go back, the IRS comes back and says, well, let me audit your books to make sure you're withholding employee taxes correctly. They're going to go through the list and say, oh my God, you're missing something. because you deleted an entire employee. And therefore, all the historical data that was collected about that employee is gone now. So typically you don't do that. What you do is you put a flag in the column that says whether it's currently active, and I typically create an extra column for like an employee table, and I call it active. And so here's the employees that are there. So instead of deleting a row, I just go into that row and turn active from yes to no, or no to yes. So it's active or not. And that way you can run query on only the current employees. You can run queries on historical employees, and none of your data gets all manged up. Okay. So you remember this thing back here where they talked about the order in which you do things? Well, multi-value dependencies they're one of those things that's mandatory. Okay, you're going to have to solve the fourth normal form issues. Absolutely, positively, no gray area whatsoever. I could cut you some slack if you had a compelling reason for not doing, first normal form or second or third or BCNF, but not fourth. Fourth is like, no, you're going to have to do this. So that's just the rules. The multi-value dependency should never, ever, ever be allowed. Okay. So let's talk about some more exceptions. On page 197, they talk about read-only databases. So yeah, this is all about modification anomalies. So let me ask you, how many modification anomalies can you have on a read-only database? None, right? I can't have any because it's read-only. So because of that, I don't have to follow any of the normalization rules on a read-only database. I mean, there may be some other reasons, for example, to make it shorter or smaller, not having duplicates. But that would be a good reason, but not for modification anomaly purposes. Okay, good. So a lot of people, because they don't want to have complex queries that slow things down, particularly if you're into big data, that's chapter 13. When we get to big data, we'll talk about how you trade off computational efficiency and disk size, okay? So I don't mind having duplicates if my queries run faster, okay? All right, so denormalization. So one more time, denormalization. So here is student and activity, and then here's the original. Remember we saw this thing where we go in here and we say, this is the list of students, and this is the list of activities, and here's the thing together. So I want to combine these guys back together again, okay? Student, activity, and payment. Okay, so let's see what we got here. I got student activity payment. Let me go look at this guy. Okay, so here's this guy. So we're going to do this. It's just a drill. We're going to do it one more time. All right, so you guys got this now, right? So obviously I need a student. We already saw that. There's no question. We need one called student and one called activity. Okay, let's just do it. Since I'm going to go ahead and just get it started. So I'm going to say select student. I'm going to go ahead and say distinct because I know I'm going to need that. Student ID. Student name. Okay, that kind of makes sense. Do I need anything more? Hey, let's go look. Do I need anything more out of that? Nope, that's it. That's all I need. Okay. From student activity payment. Okay. I need to go back to here and do the into thing. So I say into student. By the way, it's almost always singular and not plural, into student rather than students, plural. Okay, so I'm going to hit that button and boink. Okay, kind of sort of making sense. So we're going to do that again for the other guy, except we're coming up on the 15-minute mark. I guess we'll do that in just a minute.